Hi, and welcome to week number 2, where we're going to be talking about fractions and inequalities. So we're going to be reviewing the basic properties of fractions, learning various other properties such as the distribution property, and analyzing inequalities in absolute values. So the distribution property allows you to basically convert a product of a sum into a sum of products. So what this means is we can basically distribute a product over a sum. So it's very useful when simplifying or expanding expressions. Here we see we're distributing our A into our expression, and it has two terms. So we get AX plus AY. If it had 3 terms or 4 terms, we would continue that. Now here is we're distributing a sum over a product. So examples of the first one would be 3 times 5 plus 2 is equal to 3 times 5 plus 3 times 2, where the first 3 is A, 5 is X, and 2 is Y. This gives us 15 plus 6, and the result is 21. For the second example, we could say, let A equal to 4, B equal to 5, and X equal to 3. Distributing the 3 in, we see we get 4 times 3 plus 5 times 3. So this is 12 plus 15 equals, I think, 27. Now note that X minus Y is the exact same thing as X plus negative Y. So the same rules apply to subtraction as well. We hear an example is 4 minus 5 times 3. It's the same as 4 plus negative 5 times 3. So 4 times 3 plus negative 5 times 3. So this would be 12 plus negative 15, which is 12 minus 15, and the result is negative 3. Now, the following identities involve negatives, and they're true for all real numbers a, b, x, and y. So we can multiply a negative in and distribute this. We can distribute negatives when you have 2 terms. We can multiply a negative and a negative, and you get a positive. We can distribute this negative in front of the A, it can be in front of the B, or in front of both of them. We can distribute the X in something of this form of A minus B, and we can distribute A in this way too. So they're all one and the same in terms of the left-hand side equals the right-hand side. And these are all called our distributive properties. So examples of these are, let's say, negative times -7 is 7, or -3 plus 5 is going to be -3 subtract 5. The next one here is, let's say we have -3 times -5. We get, of course, 15, so positive. -3 times 5 is equal to 3 times -5, so they're same, which is equal to -3 times 5. 7 minus 6 times 8 is equal to 7 times 8, we're distributing the 8 in, minus 6 times 8. And then 5 times 8 minus 2 is equal to 5 times 8, subtract 5 times 2. Now let's say we want to simplify this. What is the first thing that we do? So let's rewrite it. Well, we want to distribute the 7 into the brackets. So essentially, by doing this, we're multiplying 7 times 3x, and then we go to the next term, plus 7 times 6y. And then we copy down the 42y. We multiply this out, 21x plus 42y minus 42y. And we see, of course, things cancel. So this and this will cancel. And we're left with 21x as our final answer. Now to expand the second question, again, let's rewrite it. So x plus y squared, well, that's the same as x plus y times x plus y. Now we're going to multiply and use the distributive property. So we're going to multiply our x with everything in here, and then our y with everything in here. And then we're going to add them because it's the next part. So let's write it out. So we're going to take x, multiply it by everything in here. So it's x plus y. Then we're going to take y and multiply it by x plus y. And as you see, when you go to the next term, it's that plus. So there's a plus here. Then we can use the distribution property again. So it's going to be x times x plus x times y plus y times x plus y times y. Now x times x is x squared. Here we have xy and yx. Well, we know that xy actually equals to yx. They're the same thing. So we have two of them. So we can put 2xy and then the last term, which would be y squared. So you have to know that. So we can see that we just shown that x plus y squared equals x squared plus 2xy plus y squared. So the following important identities arise directly from the distribution property. So this is what we just showed. So this is the first identity. This is the second one, and this is the third one, which we'll explain in a second. So please make sure to learn these identities. They're actually very important identities that you use often, especially the first one. Now it says try to see by showing this geometrically. So how do we do this? Well, we can draw ourselves a little picture. It can be kind of like a box. And let's say this is A and this is B, and this is B and this is A. So the whole thing here is A plus B. The whole thing here is A plus B, as you can see. Now we're trying to show the first identity. So the area is length times width, which is going to be A plus B times A plus B. So we can just square it. Now, if we see A times B is here, this little area. B times B is just B squared. A times A is A squared, and A times B is here. Now, if we add all these boxes up, we get A squared plus AB plus AB plus B squared. Where do these come from? Well, we see the A squared comes from here, and the B squared comes from here. And the AB comes from this one, and there's another AB over here. So we're just adding up the areas. So A squared plus, there's two of these, 2AB plus B squared. So we've shown it geometrically. An example of the third one, I'll leave the second one to you, would be, let's say, 5 plus 2 times 5 minus 2 is going to be equal to, well, 5 squared minus 2 squared. So this is 25 minus 4 is 21. Sometimes it's useful to distribute this as well, and we can see the same formula. So let me write that down. A times A minus B plus B times A minus B is going to be, this is going to be A squared minus AB plus AB minus B squared. You see that these cancel. And we have A squared minus B squared, which is the formula. Now let's evaluate 22 times 18 using like these identities. You can say a multiplication like there. So we can rewrite this as 22 is equal to, well, it's equal to 20 plus 2 where this is our A and this is our B. And 18 is equal to 20 minus 2. Again, this is our A, and this again is our B. So let's multiply them together. So 22 times 18 is equal to 20 plus 2 times 20 minus 2. Again, this is our A, our B, our A, and our B. But now we're adding and subtracting. So applying the formula, and sometimes you want to use the formulas because it's a little easier. Instead of 22, we use 20 whole numbers. You see that it's going to be 20 squared minus 2 squared. This is our A squared, and this is our B squared. This equals 400 minus 4. Our final answer is 396. So remember that all rational numbers are also real numbers, which we talked about in the first lecture. A rational number has the property that it can be written as a fraction of m over n, where m and n are integers, and the denominator here does not equal to 0. We need to understand how the basic operations work on fractions. So suppose B and D are not equal to 0. Then we multiply the numerator together, and we multiply the denominator together. Sorry, that's a D. So examples of this are 3 over 5 times 7 over 2, and we get 3 times 7 over 5 times 2, which is 21 over 10. We can also use this trick called cancellation. As long as the denominator A and C are not equal to 0, then we can cancel things out, the A's out, and we get B over C. An example of this is, let's say, 3 times 5 divided by 3 times 6. We can cancel these 3's out, and we get 5 divided by 6. Let's look at this expression and try to simplify it. So we can rewrite it in this way. Now, what's the next step that we're going to do? Well, we see that x squared minus y squared, that's an identity that we just learned. So we're going to rewrite x squared minus y squared. And what would that be? X plus y times x minus y times, and then just write everything over again. So this is by the identity. I think it's the third identity. Now what can we do? Well, we can multiply the top and the bottom. We multiply it together. So 7 times x plus y divided by 21 times x plus y times x minus y. Well, we see something clearly can cancel here. This one and this will cancel. And we're left with, let's rewrite it. We're left with 7 divided by 21 times x minus y. Now we can reduce it further because we can apply the cancellation property, because 7 goes into 21 3 times. So there will be a 3 here. But what's left over is 7 goes into 7 1 time. And then we have x minus y. Would be our final answer. Now there's division of fractions. So the reciprocal, it also has other names like multiplicative inverse of a fraction. A CD is the fraction you obtain by interchanging the numerator and denominator. So if you have C over D, you have D over C. You just flip them. That's the idea. So when dividing a fraction A over B by a fraction C over D, we just multiply A over B with a reciprocal of C over D. So I've seen it different ways, like A over B divided by C over D. Sometimes we multiply these together and these together. So you see the C over D is flipped here. Example is, let's say, 2 over 3 divided by 4 over 5 is equal to 2 over 3 times 5 over 4. And we get, well, 2 goes into 4. We want to simplify this. So this goes once and this goes twice. And we get 5 over 6. So simplify this expression. Let's rewrite it. You can pause the video and try to work on this yourself. Well, we want to multiply this by the reciprocal. And we notice we've seen this before, actually. So the denominator here, it's an identity that we've seen. The first identity. Now we can cancel, use the cancellation property, cancel this with one of these because there's 2 on the bottom. And we're left with 8 divided by 4 times x plus y. Now we can reduce it further. We see like 4 goes into 8 2 times, and 4 goes into 4 once. So we're left with our final answer of 2 divided by our x plus y. Great. So we simplified this expression. Addition of fractions. So if we were adding two fractions that have the exact same denominator, then life is easy. So if we're adding a over b plus c over b, then we just add the numerators together. So all we do is say like a over b plus c over b. It's just going to be a plus c over b. Why do we see this? Like, let's look at an example. Suppose you have a pizza pie or a circle, what have you, and it's and we're going to, our example here is we're going to add 2 over 5 plus 1 over 5. Well, we can divide this circle into 5 parts. So 1, 2, 3, 4, 5. Suppose they're equal parts. And so if we're adding 2 over 5, we want the pizza slices to be equal in order to compare them. So this would be 1 slice, 2 slices, plus the third slice, which is here, third. And we see in total, well, we get 1, 2, 3. So 3 out of 5, 1, 2, 3, 4, 5 as slices. So as long as like they have the same denominator, you can do this. Sorry, there's a little typo here. This is a D. So if the fractions that we want to add don't actually have the same denominator, then we have to make our lives easy ourselves by bringing them into a common denominator. So suppose you have a over b plus c over d. Well, we want a common denominator. So what we do, let's look at an example first. Suppose we're adding a half plus 1 over 3. So suppose this is cake and you have, let's say, half a cake, and we're adding it plus a third of a cake. Well, what do we do? Because we're now adding two different things together. So we would break this into equal parts that are common to both. So if this is a half, we can break this up into 6 parts. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So now it's a little bit easier. And we see that this half, 1 over 2, is exactly the same thing as, well, it's 3 over 6. So 3 over 6 parts. Here, 1 over 3 is the exact same thing as 2 over 6. 1, 2, 3, 4, 5, 6. So now we can add them up. So we have 1 over 2 plus 1 over 3. It's going to be 3 over 6 plus 2 over 6, which is 3 plus 2 is 5 over 6. Now, why does this work? Let's examine it. So a over b is the same as multiplying d over d, because d over d is equal to 1. Plus, now we're multiplying C over D. We want to multiply it by a number. So we're going to multiply it times B, sorry. Over B, because why again? B over B is equal to 1. So we can take a number and multiply it by 1, and you get that number again. That's that property of x times 1 is x. So it's the same number. Okay. Let's go back to blue. So this equals, well, the denominator is now B times D. And the top is A times D plus C times B. Let's just rewrite it. So A times D plus C times B, all divided by, write it, D times B, whichever way. There's a little typo here. So let's write the sum of these two expressions as a single fraction. So as a single fraction. So let's rewrite it. So 7 over x squared plus 8 divided by x times x minus 1. So the first thing we do is 7 divided by x squared. We want to multiply it by a number that's equal to 1. So x times x minus 1 divided by x times x minus 1. And we know that this equals to 1. The next part is 8 over x times x minus 1. We want to multiply that. So we're going to multiply it by x squared divided by x squared. We can multiply all this out. So we're going to get 7 times x minus 1 plus 8 times x squared. And then we multiply the denominators, x squared times x minus 1 divided by x times x minus 1 times x squared, which is equal to 7x times x minus 1 plus 8x squared. We can add them because it has the same denominators. And then the bottom is going to be just x times x squared times x minus 1. We could see like it's the same denominator because the x squared here and there's an x squared there. Here's an x and there's an x and here's an x minus 1 and here's an x minus 1. So it's the same denominator. Subtraction of fractions. So for a real number a, negative a is called the additive inverse of a. So this is the additive inverse. So think of, so subtracting a fraction from another fraction is similar to adding two fractions. So a over b is minus c over d. It's the same as if we brought the negative in front of the c. And these are all the same. So if there's a negative out front, you can bring it to in front of the numerator. And you can also bring it in front of the denominator. And they all mean the same thing, tomato, tomato. So for example, we can continue this on, and it's going to be the same as a over b plus c over negative d. So write the difference as a single fraction. So let's rewrite it. So 3 over x squared minus 5 over x times x plus 1. We can rewrite it the same trick as we did before, but we can bring this negative in front of the 5. This is plus negative 5 over x times x plus 1. Now you've seen kind of how to solve these. We can I'll write it on another line, 3 over x squared. We want to multiply it by a number like 1, which is x times x plus 1 divided by x times x plus 1. Plus negative 5 times x plus 1 times x squared over x squared. Because these are equal to 1. Now, if we multiply it out, we get like 3x times x plus 1 plus, of course, negative 5 times x squared, and then denominators. And we see that these are the same. The x plus 1 and the x plus 1, x here and x here, x squared here, and x squared here. So then we can, since it has the same denominator, we can put it all over that, add the numerators. And this negative can come out front, and then we can combine them. We can even combine the x's if we wish. Now, inequalities, intervals, and absolute values. So the positive numbers are examples such as things like 2.5, 7, square root of 3, and 0.1. These are all positive numbers. Negative numbers are things like negative 4, negative 1.3, negative 100, and negative square root of 2. And we can, again, of course, draw them on the real number line with this capital R with 2 lines. So in the center is 0. And it goes from things like 2.5, 7, we can map it onto this real number line, negative 1.3, and -4. Now, you already know some properties of positive and negative numbers, but let's go over them. So the sum of two positive numbers, of course, is positive. So 3 plus 7 is going to be equal to 10. If you have a positive number and a positive number, you're going to get a positive number. And you can draw a little sketch of this. So for example, if you have let's say 3, you add 7 to it, you're going to get 10 on the number line. The sum of two negative numbers is negative. So again, let's say you have -2 plus -5, you're going to have -7. Again, we could draw this on the number line. So we can start off at 0, and we have -2, and we add -5 to it, move in this direction, and we're left with -7. The additive inverse of a positive number is negative. This one's more fun to draw. But let's say we have a 0 and we're starting off at A. We're adding the additive inverse of a positive number. So a positive number A is negative. So it's sort of it moves over to this side. And then we get -A. So essentially, -A is a reflection of A around 0. So it is a reflection of A around the 0 mark. And then the additive inverse of a negative number is positive. So if you have -A, you're going to also then reflect and get a positive number. So it's the same thing. Kind of. The product of two positive numbers is positive. So 3 times 2 is 6. Here, the product of two negative numbers is negative, or is positive, sorry. So -7 times -2 is going to be, of course, positive 14. The product of a positive number and a negative number is negative. So 3 times -5 is -15. The inverse or reciprocal of a positive number, multiplicative inverse, is positive. So for example, 3, we take this inverse. It's also called, of course, the reciprocal. And it's 1/3. So it's also positive. And what about if a negative? So if we take -4, the reciprocal is also going to be negative. So they all mean the same thing. So those are examples. So inequalities. We're going to be talking about this section next. So consider two numbers, A and B. What does these mean? So if A is less than B, we write A is less than B if A is on the left of B on the real number line. So we can draw like a little picture of this. I'll draw it to the side. So if we have A is less than B, and this means that A is basically less than B. Now, for the second part, if A is less than or equal to B, means kind of the same thing almost. So A is less than B or equal to. So that means if you have A and B, they could be A is equal to B. If A is less than B, or this is A is equal to B. This is B is equal to A. So this means A is less than or equal to B. If B is greater than A, we can write B is greater than A like this. If B is right of A on the real line. So let's draw a picture. So here's A and here's B. So that just means B is greater than A. And what about B is greater than or equal to A? So we draw the picture again. Or B is equal to A. So it just means B is equal to A. So B is greater than or equal to A. So these are basically the same picture. And these are basically the same picture. If A is less than B is true, if and only if B minus A is positive. I'll let you think about this yourself. Note that if B is greater than A means the same as if A is less than B. Also, if B is greater than or equal to A means the same as A is less than B. So we can kind of like, they mean the same thing. You can switch them around. So we can discuss important properties of inequalities. Transitivity. So suppose A is less than B and B is less than C, then A is less than C. And we can see this on the real number line. So let's draw an example. A, B, and C. So we see that if A is less than B, just implies A is to the left of B. And if B is less than C, this implies B is to the left of C. Which implies A is the left of C. Which implies, therefore, A is less than C. So you can see this. If this is 2 and this is 5, and this is, let's say, 5 and 8, then 2 is going to be less than 8. An example would be A is equal to -8, and B is equal to -1, and C is equal to 3. So then, therefore, we're going to have -8 is, of course, less than -1, and -1 is less than 3, which implies, of course, -8 is less than 3. So we can add inequalities. So suppose A is less than B, and then, let me fix this, and C is less than D. then A plus C is less than B plus D. An example of this, I won't show you on the real number line. You can try that yourself, but let's say we have A is equal to 3 and C is equal to -1. And we have B is equal to greater than 3, so 5. And D is equal to a number greater than negative, so 6, let's say. So then we see 3 is less than 5 and -1 is less than 6. So we can sort of like add them, which implies 3 plus -1 is less than 5 plus 6, which is 2 is less than 11. What about subtraction of the inequalities? Meaning, is A minus C less than B minus D? You can try some examples, but basically the answer is no. So multiplication of an inequality. Now suppose A is less than B, then if you take a number C, a real number, and it's greater than 0, then we have A times C is less than B times C. So that kind of makes sense. For example, A equals 2, B equals 3, and C equals 7. It's great to just do little examples. And then since we have basically 2 is less than 3, and of course we have C is positive, so 7 is greater than 0, we have then therefore 2 times 7 is less than 3 times 7. So it works out. What about this one? Now this second property is when C is less than 0. Notice something, that an inequality sign changes here, changes. So I'll put a little star, that's, people kind of forget it. But let's see an example. So suppose A is less than B here, and C is less than 0, so it's negative. So an example would be 2 is less than 3, but C is going to be multiplying, let's say by -5, and a negative integer. So we have 2 times -5, and the inequality changes. So now it's positive 3 times -5, which this is -10 is greater than -15. And you can see this on the number line. Let's say you have 0 here, -10's here, and -15's here. So the inequality, it makes sense. Let's write in red to make sure. So just a little side note so you don't forget. So it changes the direction of an inequality. So multiplying with a negative number, an inequality will change the direction of the inequality. So this inequality symbol, it changes from less than to the greater than here. So a nice way to remember the second statement is to keep in mind that on any real line, multiplying a number with a negative number is like multiplication with a positive of that number, and then a reflection about that axis, or about the 0 point. So here are some examples to see this. So it is kind of similar, like let's say you have the real number line, and we have like, let's say 2 times -3, it's equal to -2 times 3. So let's say we have 0. We take the number 2, we want to multiply it by -3. So it's almost multiplying it by 3 first. So we get like, let's say 6, and then we multiply 6 by negative. So we flip it over here. So we have -6 over here on the side. Better example here would, so that's one example. Let's say we have A equals to -3 and B is equal to 7 and C is equal to -4. So we have A, of course, is less than B. So -3 is less than 7. So we want to multiply it by -4, the left side and the right side. So -3 times -4. And now we flip that inequality. So I'll just put it in another color. So it gets flipped. And then we have 7 times -4. And this is equal to 12. And this is equal to -28. So we see that 12 is larger than -28, so it makes sense. So find all the numbers x such that x minus 5 divided by x minus 8 is less than 7. Okay, so what do we do? So this x minus 8, of course, because it's on the denominator, therefore x equals to 8 is not possible, because then we would be dividing by 0, which is not allowed. What about if x minus 8? Now we're going to rearrange this equation, and then we're going to have two cases. Case 1 is when x is if, let's write if x minus 8 is greater than 0. If that occurs, what happens? This implies then, therefore, x minus 5 is less than 7 times x minus 8. We can do this because the inequality sign doesn't change, because we're multiplying. X minus 8 is positive. Now there's a second case, case 2. What happens, unfortunately, if, not unfortunately, they're just numbers, x minus 8 is less than 0? Well, this would imply x minus 5 would therefore be greater than, the inequality sign changes, times 7 times x minus 8. So we're going to examine like these particular cases. So for the first case, case number 1, we have for when x minus 8 is greater than 0, so that's x is greater than 8. And then we can solve this. So the inequality sign does not change. So that's great. So x minus 5 is less than, use that distribution property. Now we can subtract x from both sides, and we get -5 is less than 6x minus 56. Next thing we can do is add 56 to both sides, and we get 51 is less than 6x. And then we can divide by, let's say, 6, Again, x is greater than 51/6, which is the same as 8.5 less than x. So we can draw this. So the first part is when x is greater than 8. So let's just draw it. So here we go. X is greater than 8. So this is our 8. And x is over here. So these are all the numbers. Well, now let's do this part of 8.5. X is greater than 8.5. So if we have 8.5 here, opening circle, then so this part here. So this would be all the numbers greater than 8.5 is the solution. For x. So that's the first case, but we have to deal with the second case now. Whoops. So the second case, number 2, is when x minus 8 is less than 0. So how do we do that? So when x minus 8 is less than 0, if we bring the 8 to the other side, we have x is less than 8. So that's part of it, and we can draw a picture. So this is our 8. So this part here. Okay. Now we want to solve like this inequality. So we notice that it changed before this. It was x minus 5, the original question was this. And when we multiply by negative x minus 8, this is negative, the inequality will change. So we're going to get x minus 5. It's going to be greater than 7 times x minus 8. Now, of course, use distribution property. We want to, like, let's say, add 56 to the left and right hand side. So we get x plus 51 greater than 7x. We want to subtract x from both the left and right hand side. So get 51 greater than 6x, then divide by 6. So this implies 51 is over 6. It's greater than x, which also implies that 8.5 is greater than x. So for this case, the solutions are all the x values that are less than 8 because x minus 8 is less than 0 and satisfies x being less than 8.5. So essentially it's so all x values less than 8 are solutions because this is when x is less than 8.5. So let's, I'll try to say that over here. So this case, case number 2, the solutions are all values that are less than 8 because x minus 8 is less than 0, and it has to satisfy x being less than 8.5. So all x values less than 8 are solutions. So again, if we drew this one, pen color, let's change it to 8.5 here. Open it up, so all x is here. That has to satisfy both of them. So that's why it's all numbers. So this would be all numbers less than, back to the original number, all numbers less than 8.5. So combining the two conditions here, we see that all x less than 8 are solutions. So all x values less than 8 are the actual solutions. This part. Now black. So for the first case, so for x being greater than 8, or let me rewrite it. Same thing. X minus 8 being greater than 0. We have the solution is x is greater than 8.5. For x minus 8 being like less than 0, we have the solution is x is less than 8. So together, we combine everything. We draw a picture. It helps us. So solution is when x is greater than 8.5. So this is 8.5. And it goes on. And for x being minus 8 is less than 0, we have a solution of x being less than 8. So it's all the way over here. So these are the solutions. So it actually goes from this thing called negative infinity to 8 with also the solution, this is called the union of 8.5. And I'll explain that coming up to positive infinity. So those are the solutions. Some more useful inequalities to be familiar with. So suppose if A is less than B, then if we multiply it by a negative number, we're going to get negative A is greater than negative B. And you can think of like the real number line to see this. Remember that negative A is just A reflected around that 0 point. Now suppose A is less than B. Now, if A and B are both positive or both negative, then 1 over A is greater than 1 over B. Basically, the inequality sign, again here, flips. If A is negative and B is positive, then 1 over A is less than 1 over B. And this is going to be negative. And this is going to be positive. Now, some examples of this, of the first one, if both are positive, if A is equal to 2, let's say, and B is equal to 5, then we have, obviously, A is less than B because 2 is less than 5. And we're going to see here that 1 over A is greater than 1 over B. So 1 over 2, which is a half, is greater than 1 over 5. So we see how the inequality flips. Now, another example, that's if they're both positive. If they're both negative, we have A is equal to, let's say, -5, and B is equal to -4. We see that A is less than B, so -5 is less than -4. And we know this by the number line. Here's 0, here's -4, here's -5. And then also the inequality will flip though. 1 over -5 is going to be now greater than 1 over -4. And we can draw this number line. So here's 0, here is -1 over 5, here is -1 over 4. In decimal numbers, it's -0.25, and here is equal to -0.2. So you can see like this is larger than this one. And I'll leave the second one to you.